Hey everyone, welcome to the course. In this video, I'd like to walk you through the curriculum and tell you about the course projects. So if you don't care about that, if you know that you want to take this course, you can totally skip this video. But if you're on the fence or you want to know more about what I cover, let's spend a couple minutes just talking about it. So the way that this course is structured is that it's a mixture of concepts and projects. And I deliberately did not mix the two together. So I'll teach you concepts on their own, and then I'll teach you projects. That way, if you don't care about the projects, because they can take a long time to actually build a project, if you don't care about that, you can skim through it or skip it completely. But you can watch all the concept-heavy stuff about how to make requests, how GPT-4 works, the messages format, the different penalties and parameters. You can learn about that in isolation and do it relatively quickly. About half of this course is made up of projects, and a lot of that project time is building applications and working with Flask and things that aren't necessarily related to OpenAI. So, this is a general structure: concepts and then projects. You pick what you want to do. So let's start at the beginning. We're in the introductory section. You can skip as much of this as you want. I'm going to give you some optional lectures on the history of OpenAI, on the transformer architecture that powers GPT-3 and GPT-4. You can totally skip that, and please do if you're going to leave me a bad review for taking too long at the beginning of the course to actually get to the code. And then the last thing we do in this section is sign up for an account, which obviously is very important. We have to get an API key to work with OpenAI. Then we move on to our Getting Started section. We work with the very basics of OpenAI's completion API endpoint. So we do simple things. We ask it to translate English to French. We talk about some of the important API parameters, like max tokens. We talk about what tokens even are. Then we talk about the different models we have at our disposal. What's the difference between something like Babbage and Curie and Ada and DaVinci and GPT 3.5 Turbo and GPT-4? How are they different? How much do they cost? How do they perform? How slow are they? We cover all of that. Then we move on to a very important section on prompt engineering. In this section, we talk about how to write a good prompt, how to get the most out of GPT-3 and GPT-4, how to specify an output format, how to work with summarization prompts and data extraction prompts and sentiment analysis prompts. What's the difference between zero-shot and few-shot prompting? Then we move on to our first project. Like I said earlier, all the projects are completely optional. I won't be showing you any new content as far as the APIs go. It's just about building something and putting all the pieces together. So our first project is a color palette generating application. It's basically a visual search engine for colors. So we build a front end, we build a back end with Flask, nothing terribly complicated, and we use OpenAI's APIs behind the scenes to generate these colors for us. So I can ask it to give me 5 tropical beach colors. We've got ocean and sand, and it's not bad. But I can also do more specific things like give me 4 Google brand colors. And these are 4 Google colors, apparently, that Google uses in their brand. I can copy these colors, they're on my clipboard, and it's honestly a pretty useful tool if you're exploring color palettes. You want to know, what's the color of Airbnb's logo? What about Pinterest? Or can you generate me colors of a sunset? It's just a fun project. From there, we move back to some conceptual stuff. We talk about some other very important API parameters. These are more technical parameters, things like temperature and top P. And then we have a big shift in the course. We switch over to learn about the ChatGPT API and GPT-4. So this is another option we have, a different syntax and a different endpoint for interacting with an OpenAI model. It's slightly different than what comes before it in the course, but it's also incredibly powerful, and it's what we use from this point on through the rest of the course. I'll show you how the API works and how to properly format your messages and how it compares to the completion format that we also covered earlier in the course. And then we build a simple command line based chatbot using GPT-4. I can talk with it. Hi, how are you? And it will talk back to me. I'm just a chatbot. I don't have feelings. And we can, it's basically a version of ChatGPT in our command line. But I can also specify a custom personality, like snarky and rude. Let's try it again. Hi, how are you? And it will respond, ugh, like I care how I am. I'm a chatbot, not a human with emotions, but thanks for asking, I guess. Anyway, it's just a fun project to show how to use the messages format with the Chat API. Then we move on to code-related prompting. Basically, how do we ask GPT-4 to explain code to us? How do we write a prompt to have it calculate time and space complexity of algorithms, or to convert JavaScript to Python and Python to JavaScript? And then finally, how do we ask it just to straight up write code for us from scratch? And then we cover a really important short concept called cost estimation and token counting with a library called TickToken. So this helps us understand how many tokens we're using. I know we haven't covered tokens, but basically the resource that OpenAI cares about, how many resources we have in a given request, and along with that, how much operations will cost, which is really important for some of these bigger projects, like our automatic code reviewer, which is the next project. Again, completely optional. So this is a command line based assistant that reviews our code, gives us feedback, prints out a diff, but then also allows us to tell it if we wanted to make the change automatically in our code or not. So I gave it a tic-tac-toe file, and it asked me if I want to, add doc strings in. I'll say yes, and it will update my code. And it keeps repeating this process. It's an interactive code reviewer. It's surprisingly complex to make it work. Then we move on to what is probably my favorite project. It's a simple one. It's a Spotify playlist generator. So we use the Spotify API and a command line client, and it expects me to have a prompt like songs for a Halloween party, for example. It will go and get me songs using GPT-4. Here it goes. So it found songs like Thriller, Monster Mash, Ghostbusters, Somebody's Watching Me, Time Warp, I Put a Spell on You, very Halloween-centric songs, and you'll see it actually makes me this Spotify playlist with all of those songs. So I had a great time playing with this. Songs to cry to, songs to play while walking on the moon, songs that are epic, songs to drive at night to. It's a really cool project. And then we get to the hardest part to explain of the course. We learn about embeddings. OpenAI has an embeddings model that takes text and turns it into a 1536 dimensional vector. And this can be very useful when we're building things like a recommender or some sort of search. So we use it to build a movie recommender, but first we actually visualize 5,000 different movies after we've created embeddings on a two-dimensional chart like the one you see right here. It's a great way to look at and understand how your data is connected. So here we have a cluster in blue of, I think these are, Dracula, vampire movies, Twilight, werewolf movies, and we get these really cool clusters that we can just explore, but also we'll learn how to recommend movies and build a recommender. And then we have another embeddings project. I won't go into detail now. Then we have a sentiment analysis project where we scrape thousands of comments from different soccer team subreddits on Reddit. So English Premier League teams like Manchester United, Liverpool, Chelsea, we just take the top 8 most popular and we scrape the data and we perform sentiment analysis using, in this case, actually GPT 3.5 Turbo because it's cheaper. And then we generate a plot of sentiment on the different subreddits so we can visualize the most negative and positive fan bases. And then we get to the most complicated and least visually interesting project to show you, our book summarizer. So we don't build this one from scratch. It's quite complex. I just show you the source code and walk through it. It takes any large chunk of text, often a book, and summarizes it using GPT 3.5 Turbo and GPT-4. And without going into too much detail, it's a big technical challenge because we can't just provide a book at once. We have to break it down into thousands of small pieces that GPT-4 can understand and work with, and then synthesize those summaries back. So I'll show it in action. This is it summarizing Peter Pan, the story of Peter Pan, which is, it's a couple hundred pages, and it spits out this nice little summary right here. So again, totally optional. That's the most complex in terms of the code, and it doesn't show you anything new, although we work with managing tokens and cost, which is a very important part there. Then we completely switch gears away from GPT-4 to cover some of the other APIs and other models that OpenAI provides, including DALL-E. You'll learn how to use DALL-E to generate images from scratch for you, but also to create image edits using masks. Then we take a small detour to talk about Stability, Stable Diffusion, which is an open source competitor to DALL-E. So it has nothing to do with OpenAI, but I include it here because our next and final project is a Choose Your Own Adventure application. This is the Choose Your Own Adventure web app. You pick from 2 prompts. Let's do an explorer enters an interdimensional time machine. So here it generated an image. I clicked on time machine and it gives me some text as well. And then it gives me another choice. And I said the explorer sets the controls for ancient Egypt. And then it generates me another image. and then more text, and it just keeps going on and on. It's very fun. It's not a professional product, but I have spent many, many hours just playing around with this while I've been making this course. And then finally, we talk about Whisper, which is a audio to text model put out by OpenAI. It's an open source model, and we use it to translate text. So I have some fun speaking horribly, butchering French and other foreign languages, and then recording it, translating it into, translating it and transcribing it into text. So we use that model. This is sort of just a fun little half an hour at the end of the course. We don't build anything. I'm just showing you another really interesting model from OpenAI. Okay, so that was a ton, but remember, this course is divided into conceptual pieces and project pieces. You can skip all the projects if you're not interested in them, or if you just want to blow through the course in 6 hours, I don't blame you. But take a look at the source code for the projects. It's there. I spent forever making them, and I think they're really cool and fun, but they take a lot of time to actually put them together, so I don't blame you for just looking at the code and ignoring my videos. And with that said, let's go ahead and get started. Once again, welcome to the course. I hope you enjoy it. In this video, I want to give a very brief overview of the history of OpenAI. It has no bearing on the technical content of this course, but I think it's nice just to give you some context. If you want to skip it though, you're not missing a whole lot. Okay, so OpenAI was founded in 2015 as a nonprofit with one goal, which was developing AI in a safe, friendly, and beneficial way towards humankind. Today, the company is now a for-profit company. There's a big shift that we'll talk about in a moment, that still conducts cutting-edge research into machine learning and artificial intelligence. It builds very complicated models like GPT-4 and DALL-E and Whisper, but it also develops tooling and frameworks, and most notably APIs to interact with those models, paid products where we as developers can interact with GPT-4, for example, via the API. So OpenAI was founded in 2015 as a nonprofit led by a group of big tech, high-profile individuals, including Elon Musk and Sam Altman, although Elon Musk subsequently departed the company, or departed the nonprofit at the time, because of a fear of conflict of interest with the AI research ongoing at Tesla at the time. So here's a brief timeline of the days early on in the life of OpenAI while it was still a nonprofit. So OpenAI was founded in 2015. The early research projects had to do with video games and writing AIs to beat video games. So most notably, OpenAI 5 in February of 2015 was a model that defeated professional Dota 2 players. If you don't know Dota 2, it's a pretty complicated game. Elon left in February of 2018, as I mentioned, due to a fear of a conflict of interest with AI work happening at Tesla. In May of 2018, the company announced that it would no longer open source everything and publish all of its research in full due to concerns about potential misuse. Then, in December of 2018, OpenAI launched GPT-2, a large language model. We're going to talk about GPT-3 and GPT-4 throughout this course, but GPT-2 was released in 2018. It takes text as a prompt, and it returns text. It's a precursor to what powers ChatGPT. Then, in 2019, there's a big shift, a foundational organizational shift. OpenAI changes from being a nonprofit to being a for-profit company with intentions to commercially license its technologies. That's basically when it becomes the company that we know today, that we pay to have access to things like ChatGPT and GPT-4 and DALL-E and all of that. So there's a lot of pushback to this. There's some very long Twitter threads and arguments and Medium blog posts about this shift. People were pretty upset about it. The reasoning that was given publicly by OpenAI had to do with, by becoming a for-profit company, they could offer stock options to their engineers and to their researchers, basically give them better compensation packages to compete with other for-profit companies, which I guess was hard to do as a nonprofit. Again, I don't know how accurate that is, but that was the publicly given argument for this big change. So everything we see on this second timeline happened after the company became a for-profit company. GPT-3 was released in June of 2020, the next model in the GPT family. Just like GPT-2 and all the other GPT models, it takes text as an input and it spits out text as an output. And simultaneously, in June of 2020, the company released its first commercial product, which was the API to interact with GPT-3. DALL-E was released in December of 2020. DALL-E is an image generating model. It takes text. You tell it something like, generate me a picture of a snail with a space helmet on the moon, and it generates that image for us. We will work with the DALL-E API also towards the end of this course. It was a pretty big deal when it was released, but the biggest deal was ChatGPT in November of 2020. I'm sure you're familiar with it at this point. The fastest growing product allegedly in the history of the world is according to an article I just read. So it's a chatbot, a client in the browser that is built on top of GPT-3. Although now, if you pay, you can also use GPT-4 with the ChatGPT interface. And in March of 2023, OpenAI released the Chat API. So there's already been an API that worked with the GPT-3 family of models, which was a slightly different format than the chat-based API. We cover both in this class, although we mostly use the chat-based API because it is the only version that supports GPT-4. But that is something that's coming up. We'll worry about it later. And then also, I skipped over this, but in 2021, May of 2021, OpenAI released Codex, which is a model that works with code. It generates code based on text that we give it. However, it has been deprecated as of 2 weeks ago or so, and instead, we now can use GPT-4 to do the same sort of tasks. And we have a whole section in this course dedicated to code-related tasks with GPT-4. We ask it to review code, to give us feedback, to improve code, to fix bugs, to write code from scratch, to write tests. All that sort of stuff can be done with GPT-4. And that brings us to the last bullet point that gets its own whole page because it's so significant. Just a couple weeks ago, OpenAI released GPT-4, which we'll use in this course alongside GPT 3.5. Okay, so that's all you need to know for the history. It started as a nonprofit. It's no longer a nonprofit. It has lots of paid products to give developers like you and me access to their very complicated models, including, most notably, GPT-4. All right, so next I want to talk about the GPT family of models, which is what this course is mostly about. OpenAI has other models, things like DALL-E and Whisper, both of which we cover in this course. DALL-E generates images. Whisper takes audio files and translates/transcribes them as text. We cover those later on, but most of this course is about GPT, specifically GPT-4. So we do use some GPT-3 in this course. I should stop just to say that GPT stands for Generative Pre-trained Transformer. We will talk about the transformer part in the next video. It will be completely optional. I'll do a very high-level dive into transformers and the architecture behind the GPT family of models. It has no bearing on the technical stuff in this course. It's just there as information if you care. So completely optional following this video. Anyway, we have GPT-3. We have GPT 3.5, which is not a whole new model. It's just a finely tuned version of GPT-3. And as of a couple weeks ago, we now have GPT-4, which is a whole new, completely different model in the GPT family. So again, it stands for Generative Pre-trained Transformer. There's also just GPT and GPT-2, but we have pretty much no reason to use those today. And just a heads up, this course makes use of all three of these, 3, 3.5, and 4. I know the terminology gets confusing. I use GPT-4 as much as possible, but there are certain API endpoints that don't support it currently. Also, it is way, way more expensive. It's like 20 times more expensive to use GPT-4 compared to 3.5. And we can often get exactly the same result using 3.5, not to mention it can be faster. So just because GPT-4 is the new fancy thing, that doesn't mean it's always the best choice. And that's a conversation we'll have later. So all of these GPT-X models are large language models. Basically, they take text as an input, and they generate text as an output. We give it some sort of initial prompt, and the models will continue that prompt. So in its simplest form, a prompt could be something like, why did the chicken cross the? And then we ask the model, just by giving it this piece of text, it will try to complete with the next most probable choice, the next best word that it thinks fits that prompt. So why did the chicken cross the, and then road could be the next answer, the next word we get as the output. We can do things like, my favorite food is colon, and then it will fill it in with what it thinks is the most probable next word. We can do way more complicated things, right? Translate this from French or from English to French. We give it snails and it responds with escargot. These are all just simple examples. Write a tagline for a doggy daycare. That could be the text input, and it might, this is actually real. All of these examples here are real. It responded to me with cozy, safe, and fun for your furry friend. We can also do things like write 2 sentences explaining acid rain to a toddler. Acid rain is rain that has acids in it, which makes it a little bit yucky. The last thing I'll talk about is some of the training data that GPT-3 was trained on. Now, I wish I could tell you about the data GPT-4 was trained on, but OpenAI has not released that yet. So all we have is the data GPT-3 was trained on, which was a huge, huge amount of text data, over 45 terabytes of text, and it includes a subset of what's called the Common Crawl dataset. Common Crawl is an organization that crawls across the web and archives and creates a massive dataset of basically as many pages on the web as it possibly can that you can use to train models or perform analysis on. Also, databases of online books, all of the English language Wikipedia, lots of data, and this is just for GPT-3, so it's speculated that the dataset for 4 is significantly larger, but there's no evidence of that, or there's no official confirmation from OpenAI. Same thing here when we talk about the technical details of GPT-3. We don't have those details for GPT-4 just yet, but GPT-3 is a huge step up in size compared to GPT-2. Again, we can assume the same is true for GPT-4. It costs almost $5 million just in GPU cost simply to train GPT-3. And the model itself is over 800 gigabytes of essentially just numeric data in a file or multiple files. Just to store the model, it's 800 gigabytes, so it's huge. So there's a lot that we can do with GPT, but at the end of the day, we provide text and we get text as output. Typically, we provide some detailed instructions, some sort of prompt, and there's a lot that goes into engineering a prompt, which we have a whole section dedicated to coming up pretty soon in the course. So the next thing you need to know is that there are 2 main ways that we can interact with these GPT models using OpenAI APIs. There is the completion API, which expects a single text prompt, basically like what you see right here, and it responds to us with output. And this has been the standard way to interact with any of the GPT models since OpenAI first created any commercial APIs. This was the only option we had up until basically last month. So the completion endpoints do not support GPT-4. They do support GPT-3 and some of the 3.5 models. We'll talk about that. Then there is a whole separate way of interacting with these models, which is the chat API. The chat API has a slightly different format. This is what we spend a lot of time on in the course because it's currently the only API endpoint that supports GPT-4 at all. And the way we interact with it is using a list of messages in a chat-based format. So it's slightly different, but behind the scenes, it's still just a GPT model that we're talking to, that we're interacting with. It's just 2 different ways that we go about it. So in this course, we'll start with the completion endpoint. It's simpler, and then we'll move on to the chat endpoints, which is what we spend most of the course on. So just keep that in mind. 2 different ways to talk to these generative pre-trained transformer models. There's distinctions, both in terms of how we go about interacting with them, but also which models specifically they support. And right now, GPT-4 is only supported with this chat syntax, which we'll cover soon. This is a completely optional video. I'm going to talk about the transformer architecture behind the GPT family of models. If you're somebody who doesn't care at all, it's not important as far as working with the models themselves in this course. If you're someone who's going to get mad that I'm taking too long to get to the code and you're going to leave an angry review, then also please feel free to skip this video and come back if you want to learn more about transformers later. Because as I've said, you don't need to know any of this to work with the APIs. Okay, with that said, let's talk about transformers. So transformers are the type of deep learning model that powers the GPT family of models. Remember, it's GPT, generative pre-trained transformer. And they work really well at processing sequential data, which is most commonly going to be text. A little bit of recap on neural networks. They're a category of models that are very good at analyzing complex data types. And the diagram on the right is an extremely simple neural network diagram, but essentially they consist of a bunch of these connected nodes, little structures that can fire like a neuron would. like the neurons in our brains, passing data from one node to the next node, and then eventually to the output layer. There are many types of neural networks. Some of the more common ones are convolutional neural networks, or CNNs. These are commonly used to analyze images. Recurrent neural networks were kind of the go-to option for text processing, but they had some shortcomings that transformers really addressed. Both recurrent neural networks, RNNs, and transformers excel at working with text, but transformers do it way better for some of the reasons I'm about to show you. So RNNs, recurrent neural networks, process text sequentially, one word at a time. So they will go through some input text and work with a word at a time, but they have some problems. They are not good at analyzing large pieces of text. If you give it a large piece of text, can kind of think of the model forgetting what happened at the beginning of the text by the time it gets to the end of the text. They don't have a very wide window of context that they can reference at any given point. So they work well, but not with large pieces of text. Additionally, they're very slow to train. And this means that it's hard to train them on huge amounts of data. It takes way too long. And also, because they process sequentially, training cannot be parallelized. So this is where transformers come in. Transformers are relatively recent, as I mentioned, introduced in a paper in 2017 called Attention is All You Need. And what's significant about transformers is that they will process the entire input at once rather than sequentially, meaning that there's less of this problem. There still is a risk of it, but there's less risk of forgetting previous context. So there's still limitations on how big of an input a transformer can work with, but it is more flexible than working with an RNN. And this does mean that they can be trained in parallel, therefore much faster than an RNN. So how do they work? We're not going to get into much detail, but this is a diagram that is absolutely overwhelming to look at from the paper I mentioned, Attention is All You Need. This is the model architecture of the transformer. So we're not going to dive into any of this really, but you'll see that there's a couple mentions of the word attention in here. Multi-head attention, masked multi-head attention, multi-head attention. Attention plays a very important role in this model architecture. So there's really two key innovations that were introduced to make the transformer work. We have something called positional encoding and then something called self-attention. Now, positional encoding has to do with how each word or each piece of the input, we'll learn about tokens in a little bit, how each piece of an input is handled. Instead of dealing with each word sequentially, one at a time, from the beginning to the end of a sentence, for example, transformers instead encode positional data. They basically will take the positional information of each piece of the input and pass that through into the neural network. Here's a very simplified diagram of this. If our input sentence is pickles are overrated, instead of processing each word one at a time or splitting it into tokens, again, we'll talk about tokens later, instead, each input piece, we'll call it a word, is fed into the network along with its positional information. The positions or order of the content is encoded with each piece as it is passed through. So pickles is first, are is second, overrated is third. Very true sentence, by the way, pickles are overrated. This is a vast simplification of it. The model doesn't even really work with words individually, and it doesn't encode a position like this as just a single number, but it's a similar concept. When each piece of the data is fed into the network, it is encoded with positional data as it is fed in. So the word order or the token order information is stored in the actual data itself rather than in the structure of the network. And eventually the network will learn the significance of word order from the data itself. So each piece is fed in with positional information encoded. Then the second key innovation has to do with something called attention. Now, attention has actually been around before the idea of transformers, but attention basically refers to the ability of a network to selectively focus on certain pieces of input data while ignoring others. Think of how us as humans focus our attention on certain things happening around us while ignoring other things, right? I can have my attention on my phone and the basketball game can be on in the background. I'm not really listening to it. And then all of a sudden, something seems important. There's a loud noise, the crowd cheers. I can switch my attention over there and ignore whatever I was, wasting my time on my phone. Very convoluted example, but it's a similar concept where attention is what permits the network to just look at or focus on small pieces of the input data and dynamically adjust its focus as it processes the data. And there's different ways this is achieved. The most common involve basically coming up with an attention score for individual pieces of the input data and then computing a weighted sum or an average of those input elements. Here's a diagram from a research paper that's essentially a heat map of attention. Up top, we have an input sentence in English. Destruction of the equipment means that Syria can no longer produce new chemical weapons. And then we have the resulting output sentence translated to French. And I don't speak any French, but la destruction de l'équipement signifie que la Syrie ne peut plus. Okay, that's enough French. But anyway, we have the resulting output over here. And this heat map is basically showing for each one of these words where the model is focusing its attention, what it's attending to. And some things are straightforward, like equipment right here is translated to équipement. Although you can see a little bit of heat there for the le, because le and équipement are connected. They have to agree, as far as I know in French. So there's a bit of attention focused on the L apostrophe and the équipement for the word equipment. But it's most clear if we look at something like Syria. Syria right here in French becomes la Syrie, I think is how you would say it. So the la is not there. There's no the Syria. It's just Syria in English. But when the model is working, let's say, with this word Syria on the input, it's attending to la and Syrie. So that's the concept of attention. The model can basically change its focus as it moves throughout the input. Now, how does this work? Well, basically, it's learned over time. How does the model know that Syria is correlated to la Syrie, multiple words in French? How does it know to attend to la and Syrie in that example? Well, it's learned over time from tons and tons of input data, and with enough data, the model will basically learn how language works. The rules of grammar and word order and tenses, verbs, and in French, how articles have to agree, right? We have la Syrie, it's not le Syrie. So that's just learned over time with enough data. But the real innovation here is something called self-attention. This is what made the transformer model so effective and still makes it so effective. Self-attention is a special form of attention where each element in the input sequence is compared to every other element in that input sequence, and a set of attention weights are computed based on the similarity between each pair of elements. So the self here in self-attention refers to the input sequence, which is currently being encoded, each piece of it. So in this diagram that we saw earlier, we're talking about the input sequence up top and then the output sequence, the resulting translated sequence on the left in French. With self-attention, it's more about attention and focus within each input sequence. So if our input sequence is the animal didn't cross the street because it was too tired, the model will basically go through every word. Again, it's an oversimplification, but let's say it goes through one word at a time, and it will calculate attention weights for every other word. So this example has it. It, what is that referring to? The animal didn't cross the street because it was too tired. It is most strongly correlated to the word animal. So the model will go through and calculate a weight for how each word is connected to every other word within the given input. It starts to get this structure that emerges that shows how words are connected within a given input sentence or paragraph or a whole massive piece of a book. So with a small change, if the input sentence was instead, the animal didn't cross the street because it was too wide, there's a much stronger connection here, a stronger weight of attention between it and street, because that's what it is referring to in this case, right? It refers to the street, not animal, not the, but in this case, in this context, it refers to street. Now again, this all emerges with enough time, enough practice, lots and lots of data where the model is able to figure out the basics of grammar, the basics of basically what words mean and how they connect to each other. And the concept of self-attention is taking that attention idea and applying it to each piece of the input. So that's a very simple overview of these concepts of self-attention and positional encoding. These two ideas are what made transformers so powerful. All right, so next up, let's go ahead and sign up for an account if you don't have one already. So you can make a free account. You don't even have to put a credit card in, and we'll get a certain number of credits for free, but you can also put a credit card in, of course, and get access to way more. So this is the OpenAI website. I will say it's a nice looking website, but it's hard to find the button to actually sign up and to log in. I find myself never able to locate it. You can see, by the way, this morning, actually, GPT-4 was announced and went into a beta with a waitlist. So that will be a central part of this course. But if you go to product and I believe, overview, there's a get started button, and this will take us through the sign up process. So put in an email address, of course, you'll put in a password, and then it's going to ask us to verify our email. Okay, so I verified my email, basic sign up stuff. Put in a phone number, and you do have to verify the phone number. So I'm going to have to use a friend's number because I've already made an account with all my different possible numbers. It's a miracle. I made it through. I verified my phone number, my sister's phone number. Thank you to my sister. And we now have an account. By the way, I have a paid account with my own credit card set up. I just wanted to show you the process of making a new account. You'll see something like this, lots of examples, documentation. If you go to personal and then you click on usage, okay, now actually it's just $5 free that they give you. That's fine, though. That's plenty to at least understand how it all works. And you'll see a usage chart here eventually when we start actually using things. We'll talk about pricing and tokens when we understand how tokens work very soon. At any point, you can put in a credit card if you wanted to. And the good news is it's not just putting a credit card and, you can accidentally write some insane query that costs like hundreds of dollars. You don't have to worry about that because you can put usage limits in there. So once you actually put a credit card in, if you opt into that, you can then say every month, I don't want to spend more than $20 or $10 or something like that. And now we have an account set up. The next very important piece to talk about here is our API keys. So the way that API keys work, if you go to user API keys, or if you go up to the top and go to API keys right there, is you have to generate one. But it's very important to know that once you generate a key, like I'll generate a new one here, and normally I would never show this to you, but once you generate it, you will not be able to view it again. So unlike some other APIs you may have worked with before where you can go back and copy and get your key again, that won't work. The good news is, let's say I don't copy this, I can just delete it and I have to generate a new one first. I can copy this one and then delete my old one. And you can have multiple active at the same time. You don't want to, go revealing this key on the internet, for example, if your credit card is hooked up, although you can still put in that monthly limit. So worst case, someone might charge $10 to your account. You don't want that to happen. I would never advise sharing your keys, but just so you know, that's how the keys work. I can't get access to this key. I can't copy it. It's one-time access, and then you can continue to use that key. So in the next video, we'll actually get set up with our keys. So you don't necessarily need to generate one right now, but if you do, make sure you copy it and put it on your clipboard. So we've got our free account, connect your credit card if you want, and we're going to get started. All right, the time has come for us to actually get started writing some code. We're going to make our first basic request to the completion API. Very simple. We'll ask it something like to complete, what sound does a cat make? Or what does the dog say? Something like that. We're not focused on getting some exciting results at this point. I just want to show you the basic workflow and the setup of making a request. So the first thing to remind you of is that we need our API keys. Key, rather, singular. And you cannot copy them after you create them. So I talked about that in the previous video when we set up our account. So if you have not copied them, that's okay. What you can do is just make a new one. make sure to copy it, keep it on your clipboard, and then you can delete the old ones. And as soon as you revoke one, any app that's using it will no longer be able to use it. That whole key will be shut down and any requests will be completely ignored. So you can always, if you're worried someone has your key, you can just delete all your keys and start over, but you can't copy them once they're created. All right, so I have that on my clipboard. The next thing I'm going to show you is the client that we're going to use. It's the OpenAI Python library. This is the tool that we'll use to make our requests. Now, you don't have to use this. There's other ways of making requests, but just like any API that has its own client, it's typically way easier if you just use that client instead of trying to make your own requests from scratch and pass the key correctly. And this tool makes it very easy for us to make requests. And not just completion requests, we'll also use it to make image requests to DALL-E, the ChatGPT API. This client supports all of them. So it's just called OpenAI. And the first thing that I'm going to do is I'm going to work in a Jupyter Notebook because it's easier just to show you things immediately. It's better for teaching. You can also do this in just a regular Python file, but I'm going to go ahead and start up Jupyter, if I can spell it, Notebook. Okay, so I have my notebook server running, and I'm going to make a new notebook, a Python 3 notebook, and hope that it finishes soon. There it is. And I'll give it a name like our first request or something like that. And I'm going to start by installing the OpenAI tool, the client. Now, I've actually already installed this, but the command is just pip install OpenAI. And if you're doing this in just a regular Python file, then run this from your terminal. But I'll go ahead and run that. And it tells me, yeah, requirement already satisfied. We already have that installed. So instead, the next thing I'll do is just import OpenAI because I now have it installed. And I'll make a few empty cells. I'm just hitting the B key to insert cells below. And I'll show you the syntax to make our first very simple completion request. It looks like this, OpenAI dot, and then completion dot create. And as I mentioned, we'll eventually see how to use this for chat completions, to make images, to work with audio files. But for now, we're looking at the text completion part of the API. And then inside of this method call, I have to specify at a minimum two things. The first is called model. And we're going to learn a lot more about this and talk about the different models available. But what I'm going to put in here for now is a piece of text, a string called text DaVinci 003. It has to match this exactly. There are many different model names we'll see very soon. We'll talk about different models and why you might use one versus the other. But for now, just put this in there. And then another very important piece is our actual prompt. And I said we're going to start with something simple, nothing all that exciting, but why don't we say like, how about the dog says, and then I'll put a space, and the completion API will take this input and give us some output that it thinks would presumably continue this text on. Maybe the dog says arf or woof or something like that. Now, if I try and run this cell right now, I'm going to get an error. By the way, I'm just clicking run or hitting command enter in a cell to execute that one cell. It gives me an API key error. No API key provided. You can set your API key in the code using OpenAI.API key equals your API key. And that's exactly what I'm going to do. So below this cell here, or I could do it just in that cell, but just as a separate operation, I'm going to do OpenAI.API_key. And this is straight from the docs or from the helpful error message telling me exactly how to set it. And for now, I'm going to just hard code my key. It's on my clipboard, and put it right in here. In the next video, we'll talk about using an environment variable or putting it in a .env file to hide it so that our code doesn't actually include the key directly. But this is fine for now. By the way, I will be deleting this key, so if you try and use it, first of all, my credit card's not hooked up to this account. Second of all, I'm going to delete it when I'm done recording, so no need to type this up and try and get some free credits. It won't work. Well, hopefully it won't work. So I'm going to execute this cell. And then I'll move down to this cell here that was giving us an error when I tried to make my completion. And now I run it, and we get a very different output. So this output includes a lot of information, right? You can see we have things like the model object, the usage. We're going to talk about usage and tokens in a bit. But most importantly, under choices, we have an array or a list. And inside of that list, you can see that we have a dictionary that says text is woof. So the dog says woof. There's our very first official completion. Let's try changing it to the cat says meow. The pig says oink. And how about the tricky fox? What does the fox say? That's not all that helpful, is it? The quick brown fox jumps over the lazy dog. Let's try it again. What does the fox say? A woo, a woo, a woo. Sure, we'll accept that answer. Now, there's a lot that we could do to improve the completion itself, what we're actually getting for the output. We're not focused on that yet. We'll talk about prompt engineering and how to get the most out of these models and basically how to coach it to say what we want it to say, or at least format an answer in the way that we want. All that we care about now is that it's working, right? We have our API key set up and we're making our first request. And this is the syntax, openai.completion.create. And then inside of those parentheses as an argument, we have model, which for now is always going to be text DaVinci 003, and then our prompt. Let's just try one different prompt for fun. How about happy birthday with a space after it? Happy birthday to you. May life bring you all the joy and happiness. All right, so it didn't complete the song. Instead, it completed a nice, a well wish to somebody. May life bring you all the joy and happiness. Let's try one final example in this video. How do you say hello in French? Bonjour. All right, simple enough. Okay, so that's our first example. Again, we have a lot to learn, but it's working. In the next video, what we're going to focus on is just getting our API key out of here. It's generally a bad practice to have that hard-coded in our scripts, so we'll move it out and use a little library to help us import it. And then we're going to learn all about the different models and different types of prompts we can write and how to optimize our prompts and how things are priced and what's going on with tokens. There's a lot to cover. So that's coming up, but congrats on making our very first request. Welcome back. Next up, I'm going to talk about moving our API key out of a notebook file or a Python file. It's generally not a good idea to have our key hard-coded right here because I can't really push this code up to GitHub. I don't want to share it with people, right? My key is then going to be out in the wild. So a way more common approach, and a lot of you have probably seen this before, is to make an environment variable or put your variables in a file, usually a hidden file called something like .env, like this. Whoops, not RNV, env for environment. Some people call these .env files or .env files. That's usually what I say. It's just a file that's hidden, meaning you don't see it. You know, when you just look at your files, it's still there. It's not like secret or anything. But typically, we're not going to then push a hidden file up to GitHub, for example. We can ignore that file. And then a user will just know, all right, I need to go make my own .env file and put my own API key in there. So instead of putting our key right here, what I'm going to do is make a file in the same directory as my notebook, or if you're writing a script in the same directory there, I'm going to call it .env. And if you've never seen hidden files, they start with a dot. If I look in here, we don't see it, but if I use the -a flag, you can see .env. You could also do this in the notebook itself. If I go to the notebook server, I could go to new file and then make a file called .env. I'm going to open it up in a text editor. Here it is. And can I make the font bigger? Very slowly. Okay. And the way that we format these environment variable files is that we'll have something like a variable, let's call it color, for example, and then we can set that equal to a value like red. And maybe another variable for, these are all just hypothetical things like flavor equals chocolate. Actually, how about mint? No. How about cookies and cream? All right. So this doesn't do anything. If I save this file, it's just a text file called .env. What makes all of this work is if I then go load this file, specifically I'm going to load the file using a package called python.env. And if you get lost at any point here, one option is just to push on with your key hard-coded in the file. Just don't share it with other people. it's fine. And if you're worried someone else has it, just delete the key. But that's not how I would, do this in any sort of professional environment, any real project. But if you're following along, security is not going to be really much of an issue here if it's just on your own machine, especially if you don't even have a credit card connected. So to use this package, we'll install it. I've already done that, but I'll go ahead and run it again just so you can see. Python-.env, requirement already satisfied, but make sure that finishes installing. The next step, once I've installed it, is there's a couple of ways of going about this. What I'm going to do is use a function called .env values. So from .env import .env underscore values. And this function here that will load and then we'll be able to execute is going to expect us to provide a file name, so .env values, where our environment variables are held. And we called that file .env. Now, I put this in the same directory as my notebooks, and that's probably what you want to do. That way I can just write .env. I don't have to give it some specific path like /blah/.env. Wherever the location is of that file, load it using .env values. And this will return to us, I'm going to call it config. And if I look at config, it's an ordered dictionary that has key value pairs. Color is red. Flavor is cookies and cream. So I could access something like color out of there or flavor. But what I really want to do is put my API key in my .env file. So I'm going to copy it and then come up with a variable name like OpenAI API key. And we don't put it in quotes. That's important to note. So we don't do that. We just put it directly in there like that. I'm going to save my file. And then I'll leave all of this the same. I'll load all the .env values from my file called .env. And then I'm going to look for config of OpenAI API key. It needs to match exactly what I had here. These don't have to be like all caps, but conventionally they should, or they are. So now I'm getting my key here. Great. And then I'm just going to pass that through on this line. So OpenAI.API key equals whatever we found in my .env file under the name OpenAI API key. So I can delete this cell. And now I should verify that it still works. And in case it was still using the hard-coded key, I'm just going to restart the kernel, which basically stops and starts Python. So I'll run all of this again and just prove that it still works, one at a time. And there we are. How do you say hello in French? Bonjour. So now I don't have the key in here, and I could push this up to GitHub and share it with you or anyone else, and they wouldn't know my key. Of course, they would need to make their own .env file and put their own key in there, so we probably want to have like a README file or something explaining how to get this code up and running. But there we go. We've got our API key hidden away, and we're still able to make requests. And next, we're going to learn a whole lot more about making those requests. Next up, we need to talk about tokens. So before we can address all the different models that we can put in this model argument here, we first have to understand a little bit about tokens, because one of the key differences between the different models is how many tokens they can work with, their pricing per token. So let's start by understanding tokens. So all of these models, all the text-based models, not like DALL-E for images, but text-based models, whether it's code completion or text completion or a chat completion API, they all work with tokens rather than words. So the inputs are going to be words. For me, they're going to be English words that I'm feeding in. However, the model itself is going to split those words into a bunch of different pieces. Basically, a token sometimes is a full word. A lot of the time, it's a piece of a word. On average, it's about 4 characters of English text. So if I feed in the piece of text, I like hamburgers, that is 3 words? 1, 2, 3. But this is actually how it's split into tokens, and I'll show you how you can view this. So this is its own token, and then space like is a token. Space hamb is a token. Erg is a token, and ers is a token. So it's not just that the model works behind the scenes by splitting words up into tokens. It also matters, more importantly, because we are billed based on the number of tokens in a given completion request. OpenAI will charge us based on the total number of tokens in our input plus the total number of tokens in our output. And different models have different prices, which we'll talk about very soon when we learn about all the different models. But some are cheaper, some are more expensive. Generally, the better ones are more expensive per token. There is a tool called the Tokenizer. If you just search on Google for Tokenizer, you'll find it. This tool will show us how the GPT models process our input text as tokens. So if I had something like, what are the top 10 most, populated cities in the world? That's some number of words. I won't count them, but it's some number of words, but it's 12 tokens. And you can see a lot of these tokens here actually are full words, although they have a space, usually a leading space. It doesn't look like any of those are actually split, but if I try another one like I like hamburgers. This is what I showed you on the slide. Hamburgers is split into 3 different tokens. So 5 tokens for that input. So you don't really have to understand how it splits them, why it splits them at certain places. Just know that tokens exist. So that's the first bit about tokens. In the next video, I'm going to show you how we can tell the API how many tokens we want in the response, so we can control the length of its response to us. So now that we have an understanding of tokens, the concept again is that the words we provide, the text, to an API will be split up into a number of tokens that are roughly about 4 characters per token, although it varies quite a bit. And this matters for a couple reasons, one of which I'm going to show you in this video, but also it really matters for pricing, because the way that we're charged by OpenAI is by taking the sum of the input tokens plus the output tokens it generates for us, summing them together, and then billing us on a per token basis that varies from one model to the next. Again, we'll cover more about that soon. But what I want to show you in this video is how to control the maximum number of tokens we get back. So I'm going to start by just duplicating our existing notebook. You could also just do this in the same file that you're already working in. Here's my new notebook, if it loads. Okay, I'll give it a new name. I'll call it max tokens. I'll rerun all the cells to import OpenAI, import.env, get our env value, add in the API key for OpenAI. And then instead of asking how to say hello in French, I'm going to ask it something like, complete the following. The top 10 most populated cities are, and then I'll put a colon and a space. I could also ask this in the question form, what are the top 10 most populated cities? But I'm just going to use this form here where the colon indicates that I want it to continue by filling out what it thinks should come after this text. And hopefully we get a list of the top 10 most populated cities. And we kind of do. We see Tokyo, Japan, and then number 2. So it's putting them in a numbered list. It's putting them in a list, right? We have 1 and then 2. The \n is indicating a new line character. So these would be formatted on separate lines. Then we have Delhi, India, and then it just stops. It looks like it's going to keep going. 3, but then nothing comes after 3. Why is that? Well, if we look at this finish reason right here, this tells us why it stopped completing text. And there's different options, different reasons it will give us. We'll see soon. But this one here of length, this finish reason tells us that it stopped because it hit its endpoint in terms of length. By default, every request that we make, if we don't specify otherwise, will have a maximum generated response of 16 tokens. If you go to the documentation, the API reference, so you can get there by going to documentation when you're signed in. On the left side, we can go to text completion. That's actually the guides. We want to go down to the API reference. We can go to completions. And then it shows us all the different parameters that we can pass as part of our request. So we've already seen model, although we haven't really played around with the different models yet. That's coming. We've definitely seen prompt. Keep going down. Max tokens is what I want to cover now. Notice that it says it defaults to 16. This parameter in the request specifies the maximum number. So it's not the desired number. It's just the maximum number of tokens that we want it to return to us. It defaults to 16, which is why we're hitting this length. It's not an error, but this finish reason of length. So I can specify something else. There are upper limits depending on the model you're using. They vary from 2048 maximum tokens of the content or 4096. And GPT-4, which is still in beta as I'm recording this, allows up to 81 or 8200 tokens in its content. So there are these upper limits, but we don't really need to worry about that for now. I just wanted to give me the list of the top 10 most populated cities, and it's stopping after 16 tokens. So I can say, nope, your max tokens count is actually, let's say, 100 tokens. That might be enough. I'll run it. Okay. Now we got a different finish reason. It says stop, which is the AI or the API's way of saying it was a good stopping point. There wasn't anything else you asked for. It seemed like a natural place to stop, right? So I asked for the 10 most populated cities, and now it gives me 10. Now, the total number of tokens that was actually used is only 64, as you can see right here. The prompt itself had 9 prompt tokens. This right here. That's 9 total tokens. And then the response, the continuation of the text I provided, is 64 tokens. It could have been more. I said you can go up to 100, but it didn't need that. And then the total tokens that were billed by is 73, right? Those two numbers summed together. Again, we'll talk more about pricing, but why don't we just check in on my usage? So if I go to my account and go to usage, you'll see that I have so far spent a grand total of 1 cent. And I actually have recorded a couple videos so far 2 or 3 times. I wasn't happy with how they turned out. So it's really less than 1 cent. If you're following along with me, it's far less than 1 cent. It's like 0.00000. There we are. This is the request I've sent today, which is just 2 or 3 requests, a very tiny fraction of a cent. So not expensive when we're doing things like this, but it can be expensive-ish, a couple dollars if you're trying to summarize a massive book and making like 100 requests in succession. We'll have a project on that soon. So that's max tokens. Of course, you can set this to whatever you think makes sense. If you're doing something like give me the top 10 most populated cities, you probably don't need very much. But if you're going to ask it to generate an essay for you or something like that, you definitely want to increase the max tokens. And just remember that the default max tokens is 16. So if you're ever getting a truncated answer that doesn't seem complete, it's probably because max tokens is too low. So next up, we're going to talk about another important request parameter we can provide called stop. So I've made a new notebook. I'll just do this for each of these parameters, but there's no reason you really need to do that. I'm just separating them out. And what I'm going to do is make a request. So OpenAI.completion.create, and I'm going to ask it to generate a list of the best movies of all time. So prompt will be generate a list of the best movies of all time. Okay. And then, of course, I have to specify the model, which we still don't quite understand much about, but I'll do text DaVinci -003. And if I just run this right now, I need a comma. It gives me a list. It's stopping after 2 movies. Why is that happening? Well, as we just learned, I need to specify max tokens. Otherwise, it will stop after 16 tokens as the maximum response length. So let's give it 200. And we wait. And we still wait. Okay. And here's my list. And you can see the way that it's given me this list is if I print this out, it will certainly look a lot nicer. So maybe I should do that just to show you. If I did put that in a variable, we'll call this response. All right. And then if I look at response, we know that inside of it, we have choices, right? So I can do choices and then text. of, I guess it's 0, right? There's only one choice. Here we are. So this is what it gives me. And if I just print this out, there we are. You can see how it's formatting it, right? So it's formatting it in a numbered list where it's putting new line characters, which are actually in here, of course. We just don't see them actually rendered when we print the response. But it's giving me a list of 15 movies here. And let's take a look at the response just a bit more to see why it stopped. So it finished. When it says stop, that usually just means that it felt like it was a logical place to stop, although I shouldn't say it felt like it, but it reasoned, or the model decided that it just was a good place to stop, right? I didn't ask it to make 15 specifically, but it's not going to go on and make 1,000 movies in this list. It just picks a natural place to stop, although I could tell it exactly how many I want. But the other thing that I can do, that I'm going to show you right now, is I can specify a stop sequence or sequences. So on the API reference, if you go to making requests, and I scroll down here to under completions, we have things like max tokens we already learned about, and then we have stop. And stop is either a single string or an array of strings that specifies one or more sequences where the API should stop generating further tokens if it encounters that sequence. So if it generates, the word sunset, let's say we're having it make a beautiful poem for us that's thousands of tokens. As soon as it says sunset or is about to return sunset, stop generating further tokens. And it's important to note the return text will not contain that stop sequence. So I could use this here. This is kind of a silly example, but I could say, I want you to generate a list of the best movies of all time, but I want you to stop right before you generate 5. If we look at the syntax or the pattern it's doing, right? 1 period, The Godfather, new line. 2 period, Shawshank Redemption, new line. So as soon as it encounters 5, I want it to stop. And it won't include 5, so it will stop here. So let's try that. Run that again, print out, and there we are. You can see that it stopped right before it encountered 5. Never mind the fact that I could actually just say generate a list of the 5 best movies of all time, and this will probably just give me 5. But I wanted just to show an example. There we are. Well, this is actually technically different because I was generating 4 in the previous example, right? This is stopping after 5. My previous example was stopping at 5. Anyway, that's one example of using the stop sequence. You can put an array in here as well, or a list, and have any number of stop sequences. And if one of them is encountered, the response will be done. It will no longer generate further output. So I'm not going to ask it for 5. I'm just going to say generate a list of the best movies of all time. And maybe I'll say stop right before 11. So this should give me the top 10. And we saw that by default, it looks like it was doing 15. So this now gives me 10. So that's one use case for the stop sequence. Another place it can come up is if we're working with chatbots, or if we're creating some sort of chat-based completion. There is a ChatGPT API that we will learn about, but there didn't used to be up to like 2 weeks ago. It didn't exist. So what we would do to make a chatbot is create a pretty long prompt that would look something like this. I'll do it as a separate variable. I'll do a triple quoted string, and I'll give it some directions like you are a chatbot that's, let's do a toddler chatbot that speaks like a very young child, or I guess we'll just say toddler. And then I prompt it by saying, here's what the user says, and here's what the chatbot says. So maybe the user says, hi, how are you? And then the chatbot says, I'm good. And then the user says, tell me about your family. And then the chatbot says, and I'm just giving it some basic context to set up a conversation that I want it to continue. So the chatbot then will say, I have a mommy and a daddy and a sister. Maybe we'll call it, we have a baby sister and 2 kitties. Okay. And then the user will ask a question like, how old are you? Or what do you do for fun? So if this is our prompt, right, it's kind of a long prompt. So I'm giving it a tiny bit of instructions and then showing it a pattern. Here's what a user says. Here's what a chatbot says. Here's what the user says. And then I can simply say, I want the chatbot to respond. So it will figure out, hopefully, based on this pattern, that I want it to respond as a toddler chatbot. So I'm then going to pass this prompt through. I'll just copy this here and change my prompt to be my prompt variable, and I'll get rid of the stop sequence. And what am I missing? Once again, a comma. Okay. So here we are. You can see it completes the text. I like to play with my toys, color, go outside and explore, play with my kitties, read stories, and play games with my family. Okay, so that works, right? It's giving me the next line in this conversation. However, what I want to show is that sometimes it might keep going on further than we want. So I'm going to plug in the response it just gave me. And then I'm going to do something different. I'm actually going to prompt for a user. So it's going to try and figure out what the user would ask next. And when I run this, this is what I see now. That sounds like so much fun. What's your favorite game? That's coming from the user. And then it decides, okay, well, the chatbot also responds. I like to play hide and seek. It's so much fun. Again, this is kind of a silly example, but what I'm showing here is that it's just going to continue on with the conversation, and it will kind of figure out where it thinks it should stop. And in this case, that means completing the user's response and also continuing on as the chatbot. I may not want that. I may want it to only give me one line at a time, one role at a time, the chatbot or the user. So I can tell it, I want you to stop before you say anything about the chatbot again. And that's where the stop sequence list can come into play. I can say stop right before you say chatbot : and right before you say user : And now it only gives me one line at a time. That sounds like fun. What's your favorite game? Right? And then I can plug this in as the user's response and then ask for the chatbot to respond. My favorite game is hide and seek. Okay. So just a simple example, right? This isn't really this is actually how you could make a chatbot where you store each response and you keep growing a massive prompt every time. That's really what you do. But there are better options. We could write something using some functions to help us create a chatbot. We'll learn about chatbots in the ChatGPT API soon enough. This is more just about preventing it from blathering on further than we want by using the stop sequences. In this example up top, I just used a single string, but you can optionally provide up to 4 strings in this list. Welcome back. Next, we're going to talk about 2 other important parameters when making a request, echo and n. And again, I'm doing this in a separate notebook. You don't have to do that. It just means that I can attach this to each video. Each video can have its own corresponding code. So the first one of these parameters we'll look at is called n. N allows me to specify how many completions I want. So it defaults to 1. Right now, we just get 1 result. Every time we're making a request, we get 1 answer or 1 completion output. If I change n to 3, for example, then I will get 3 different completions for the same prompt. So if I write a basic completion, how about I ask it to tell me a joke? Let's do our model equals text. DaVinci, don't worry, we're still going to talk about the different models and what this means. And then my prompt will be something like, tell me a joke about what? About death. Okay, getting dark. And then I'll set max tokens maybe to be 100. And as we already know, this should give me 1 result. Okay, here we go. So all of our data, as always, is inside of a choices property, which is a list. And in that list, there's only 1 element for now. The text property says, why did the cowboy die with his boots on? He didn't want to stub his toes when he kicked the bucket. So I can use n to instead get 3 jokes, for example. And now my choices property will have a list with 3 elements, and each one is a separate completion. What did the ghost say to the dead policeman? Your shift is over. Why was the ghost mad? Because he realized he was dead serious. Why did the ghost go to the bar? For the booze. All right. So 3 different completions there. There are certain situations where this can be useful. You might be wondering, well, couldn't I just ask it to give me 3 jokes? Tell me 3 jokes about death. And absolutely, that should work. Although I may need to specify different max tokens. We'll see if they all fit. What did the ghost say to the other ghost? Do you believe in life after death? What did the vampire say? I don't have a pulse. What did the headstone say to the grave? Been nice knowing you. So it did give us 3 jokes. It numbered them 1, 2, and 3. You can see there. Don't get distracted by the new line characters. Remember, we can always extract this and print it out nicely so we can see it rendered without all those new line characters. But you can tell it worked, right? We got 3 jokes. The difference is that it's one big piece of text. And so if I want to work with those jokes individually, what I could then do is figure out how to split them up. How do I decide where the joke starts and ends, right? If that's one joke, here's the next joke. I would probably look for the numbers, right? And then split after that. I'd have to write some code to do it. That's the point. If I get one big response that has 3 small jokes inside of it, I have to do some work to get those jokes out and then maybe render them to a user or save them to a database or whatever the use case is. I have to do some splitting of this bigger piece of text. When I set n equal to 3, and if I go back to just tell me a joke, and how about instead of death, let's do a joke about snakes. Missing a comma somewhere? Yes. Now, when this finishes, if I want to work with each joke individually, it's super easy. They're just in this list, right? And I look at the text property. Here's the first joke. I can keep looping. Second joke, and here's the third joke. Now, there is one thing I need to be careful about with max tokens and n. When I set max tokens to 100, I'm not saying I want the total number of tokens for all my completions to be 100. It's actually saying for each one of these, it can be up to 100 tokens. So what do we see here? Completion token was 88, so it stayed under 100. But if I did something like, instead of tell me a joke, write me a poem, but I'm doing that 3 times, very directionless prompt, just write me a poem in general. I've asked for 3 of them. Whenever this decides to finish up, there it is. If I scroll down, you'll see that our completion tokens was 300. So it used as much as it could for each one of these. 100 tokens here, 100 tokens there, and 100 tokens here. So you have to be careful with just, if you're using n and trying to get like 10 completions, if your max tokens is set to 100, you're going to possibly have 1,000 tokens in those completions. So you're not restricting the total number across all completions. It's the number of tokens for each completion. And the default is that we just have one completion, so it would use up to 100 tokens for that one. But when I have n set to 3 or 5 or whatever, each one of those completions can be up to 100 tokens. So it can get expensive. Still, we're talking about fractions of a cent for something like this. But if you're doing something complicated with a lot of tokens and a high number for n, then you can probably get up to multiple cents, if not dollars, if you're doing something crazy. Although probably not for just a single call. Anyway, that's n. Again, the main reason I would use this, even if you could say, write me 3 poems and get a very similar result, is that this allows us to work with each result separately and iterate over them, not have to split things up. It just makes our life a little bit easier when we're actually building something with this resulting text. And then the second attribute I'll show you is a very simple one. It's called echo. And echo does what it sounds like. If we set it to true, it's just a Boolean. It defaults to false. If I make it true, it will echo back our prompt in addition to the completion. It basically includes the prompt in our completion. So I'll show you an example of that. Let's just make a couple more empty cells down here. And instead of write me a poem, I'll do something like question, what is the tallest building in the world? All right. And then max tokens 100 is fine. I'll get rid of n, set to 3. Let's just see what kind of response it gives us. Answer: the Burj Khalifa, located in Dubai, is currently the world's tallest building, standing at 828 meters tall. Okay, if I set echo to true in here, now my response also includes the original input. It includes the prompt. Sometimes you may want this. It can make formatting the output easier. Like in this case, if I want a question followed by an answer, if I could manually just take this prompt and add the answer to it, concatenate them, and that would probably be easiest. But if you're working with like a chatbot where you have a whole history, I showed some of this in the previous video, if we have a history like this, I may want to include that in my output so that I can easily see the conversation and then also feed it back in to the prompt next time through. And in case you're wondering, does it impact pricing? Notice here it says completion tokens is 35. Okay. The prompt tokens was 11. The total tokens was 46. If I turn off the echo, I go back to the default of false. It's still going to show me, it's a slightly different answer, but completion tokens is 42 in this case, prompt tokens is 11. I could probably demonstrate this in a clearer way if I just had it give me a single word. What is the color of a pickle? And I'll say in a single word, what is the color of a pickle? And the reason I'm going to do that is so we can have a baseline to compare. So the answer it gave me was green, and that took 4 tokens. The overall total tokens was 19. And if I turn on echo, I already have it here. I'll just uncomment that. You can see the text that it gives me back is in a single word. What is the color of a pickle? Green. But the completion tokens is still 4. So in other words, we're not going to be billed for using echo. It's charging us based on the actual completion that it did, which is this part. Using echo just changes the format that it spits back to us after the completion has been done. So sometimes you want that initial prompt combined with the answer or the output. And instead of doing it yourself manually, if you set echo to true, it will combine them for you and give that to you as the text. Remember, it doesn't charge you more. Okay, that's it for echo and n. Alrighty, so next up we're going to talk about the different models that we have at our disposal. And we'll hopefully understand what this model equals text DaVinci 003 means. By the way, I have a new prompt. I'm sad. Make me happy, please. Let's see if it can replace my therapist. Wow. All right. Well, that's too much to read out loud. But it seems like it's giving me some suggestions. Get some fresh air. Go for a walk outside. Well, it's currently 12 degrees out and pitch black in the middle of the night. Cuddle up with a pet or loved one. All right. I can definitely do that. Got 4 cats and a dog. Listen to upbeat music. All right, let yourself have a good cry. I'll be sure to do that as soon as I finish recording this video. Okay, so in the world of OpenAI, there are these different families of models, and some of them have to do with text completion, the stuff we've been doing so far, where we provide some input text and we get some output that's generated based on that prompt. Those would be GPT-3, 3.5, and 4. But then we also have things like DALL-E, which is an image generating model. You've likely seen it or heard about it. We'll cover that later in the course. We provide it some text and it gives us an image. It can also edit images these days and add things into images. We have Whisper, which is a relatively recent addition that will take audio, like speech, in a file and convert it to text. There's Codex, which is actually kind of related / intermingled with our text completion APIs. Codex works with code. We can provide some code and ask it to complete the code or to fix it for us, to write some function that we want it to write. It's all about working with code in different programming languages. We have the moderation APIs and models that have to do with text and detecting unsensitive, inappropriate, or unsafe content in that text. These are the main families of models in the world of OpenAI. What we're concerned with for now are GPT-3, 3.5, and 4. those are all going to work with text. So we provide input text and a prompt, we get output text. Now, there's key differences between these, 3, 3.5, and 4, and there's key differences even within each of those families. There are specific models like Text DaVinci 003 that we can choose from. And one thing I want to recap briefly, GPT 3.5 is not an entirely new model. It is a finely tuned, sort of fixed up, enhanced version of GPT-3. So GPT-3 was released in 2020. GPT 3.5 was developed in 2022, and it was trained on some more recent data through 2021. But then, yesterday or 2 days ago, OpenAI announced GPT-4. And everyone knew it was coming, but they actually opened up the waitlist. It's in beta at the moment. I did get access, and by the time you're watching this, I'm hoping it's just going to be open to everyone. That may not be the case, but what you should know either way is that GPT-4 is a new model. It is not just an enhanced version of GPT-3. It is a massive new model trained on lots and lots of different additional data. And we'll have a separate video discussing GPT-4, but just know that it is a new family of these models that we can pick from if you have access, which, like I said, I do have access, but you may not, depending on how long they take to remove that waitlist. So within each of these groupings, GPT-3, 3.5, and 4, there are specific models that we can pick from. So this is a page of GPT-3 models, the oldest family. And within this page, you can see that there are models named after famous scientists, artists, researchers, computer scientists. So, Leonardo da Vinci, Marie Curie, we've got Babbage, Ada. And the reason that there are these different levels is that basically we can pay more to have a more capable model that might be slower, but higher quality. Or we can pay a lot less for a model like Ada down here, that is less capable, but faster and much cheaper. And then between them, we have Curie, which is the second most capable, and Babbage, which is the third most capable. And I'll show some examples of, trying to illustrate when they say less capable or more capable, I'll show you what that looks like in practice. Just know that they're priced accordingly. So Da Vinci is the most expensive, Ada is the cheapest, and I'll show you some pricing information in a moment. And then we have GPT 3.5, which brought an enhanced version of these GPT-3 models. And you can see down here, we have Text DaVinci 002, Text DaVinci 003. So Text DaVinci 003 is currently the most capable model for doing text completions. There's GPT 3.5 Turbo. This only currently works with the ChatGPT API that we'll see soon. So if I tried to use this with our completion request, it won't work. I can just show you this very quickly. If I change this to be GPT 3.5 Turbo, it's going to complain to me that this is a chat model and not supported in the completions endpoint. I imagine that will change eventually, but for now, this GPT 3.5 Turbo model only works when we're doing the chat API. And we'll come back to this. This will be a theme throughout the course because it's actually quite cheap and it's faster than Text DaVinci 003 and more powerful. However, it does not work for text completions. So for now, Text DaVinci 003 is our best choice. 002 is very similar, but it was trained slightly differently with supervised fine-tuning. That won't really matter for us in this course at all, but that's a distinction. And then there's a family of GPT-4. None of these models currently work, even if you're on the wait list or if you're through the wait list and you have access like I do, they won't work with the text completion API. So same deal here. If I put in GPT-4, it doesn't work. It also says this is a chat model and not supported for completions. Did you mean to make a chat completion? And if you're confused what that is, what's the difference? Don't worry, and you're not alone. It is confusing. The way that it was all rolled out is a little hazy, I would say. There's not a lot of clarity from OpenAI on their long-term strategy for which APIs they want to push us towards. Anyway, we'll come back to that. We'll learn about the ChatGPT API. We'll learn about GPT-4. But for now, with what we have been doing, making these completion calls, our choices are Text DaVinci 003 or 002, or any of the models you see on this page here. In this course, I'll pretty much exclusively use Text DaVinci 003 because everything is priced relatively cheaply, where if I'm just showing you some examples for making projects, it might be a couple of cents here or there. Now, if this was, an enterprise level project or startup or something where we're dealing with thousands of requests a minute, then certainly it would make sense to consider some of the cheaper models. So speaking of pricing, here's the latest pricing data. I imagine some of this will change, but you can see Text DaVinci 003 is 2 cents per 1,000 tokens. Compare that to Curie, which is 10 times cheaper, right? It's 0.2 of a cent for 1,000 tokens. Babbage is $0.005 for 1,000 tokens. Ada is a little cheaper, a lot cheaper, sorry, $0.004 dollars per 1,000 tokens. And then we have GPT 3.5 Turbo, which is currently not enabled with the completion endpoints. I already showed a minute or two ago that it didn't work. It told me this is not a valid model for this type of request. It will only work for the chat requests, which we haven't learned yet. But it is a lot cheaper. It's 10 times cheaper than Text DaVinci 003. And it's also substantially better. So it's better, more optimized, and cheaper. So we will prefer to use this when we have a choice. We just don't have a choice for the text completions yet. And then finally, the GPT-4 models, which are brand new. As I mentioned, you have to be on a wait list as of today. I'm sure that will change. They're a lot more expensive, 0.06, 6 cents to 12 cents per 1,000 tokens. That will vary depending on which flavor of the model you're using and the size of their context window, basically how many tokens they can work with. But as I already showed, GPT-4 models don't work with the completion API either. So we're looking at, for the completion API, with what we know how to do so far, Text DaVinci 003, 2 cents per 1,000 tokens, or Curie, Babbage, or Ada, which get significantly cheaper as you go down that list. So I know it gets confusing. I mean, it is confusing, all the naming, the numbering, the different families of models, which ones work with which API endpoints. But the simple thing that I want you to take away is that Text DaVinci 003 is currently the most powerful, also the most expensive and slowest of the models that we can use with the completion endpoint. And it's what I'm going to use for now in this course until we get to the ChatGPT API sections where we can use 3.5 Turbo and GPT-4. Okay, so now I want to demo some clear differences between these models and the quality of the output that we get. We can do this in a script. It's just a little bit clunky doing it this way to toggle back and forth and show you the differences, but I'll just show an example. Here I said, I'm sad, make me happy, please. Let's limit it to 100 max tokens, and we'll use 003, so Text DaVinci 003, which we've already done. And here it is. It gives me some output. It generally makes sense. I'm sorry that you're feeling down. Here's an idea to help lift your spirits. Try to do something that makes you feel positive, like listening to your favorite music, blah, 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 blah. Okay. Now, if I downgrade this to, should we jump straight to Ada? I guess let's do Curie 001. And we get something a little less exciting. Okay, I'll try. What can I do to make you happy? Let's keep going down now to Babbage. The text is just, I'm happy. Thanks. Thank you, Babbage model. That really makes me feel great. And then if I go to Ada, it says, I'm happy when you make me happy. Okay, so, there's definitely different levels of quality here. Generally, I stick always to DaVinci 003, but like I said, if you're doing something at a large scale and it's a simple task, like Ada is perfectly capable of simple things. I'm going to use the Playground to demonstrate this. So if you're logged into OpenAI, if you go to Playground, you can select from the different model or different features in different modes. I'm going to go to Complete, and then I can select which model I want to use. And they actually tell you a little bit about each model here. most capable model in the GPT-3 series, blah, 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 blah. Strengths, complex intent. Cause and effect, creative generalization, search, summarization. If we go down to Ada, the strengths are parsing text, simple classification, address correction, keywords. So simple things, but if you're trying to extract keywords from 1,000 different things every minute, and it's 50 times cheaper to use Ada over Text DaVinci. Well, if Ada gets the job done, might as well use Ada. So again, I'm going to stick to the more powerful models that are generally just better when I'm teaching. But if I was building an app at scale, I would definitely try every tier down and see at what level the quality started to suffer. So let's do something super simple, like how about extract the airport code from this ticket stub or something. And we'll just have a piece of text that says, time 5:66, 5:12, airport, how about LAX, and passenger, imagine this is data coming from like a database or something, passenger Mr. Steele. Okay, so what I'm hoping it can do is extract LAX. That's an airport code in the US for Los Angeles International Airport. If I use Text DaVinci 3, it's able to extract that, LAX. What about Text Curie? Oh, I need to get rid of this, by the way, if you're using the playground, because it thinks I've already completed it. So let's try that again. It also extracts LAX. Babbage. LAX. All right, looking good. And Ada. Meh, not really. No. The airport code for LAX is STX. So, with enough testing and enough just iterations, you could probably decide if you could get away with Babbage. It worked in one example. Obviously, that's not going to tell us enough to use it in a production application for this purpose. But the point is, if we're doing simple things, we might be able to get away with these cheaper models. But as soon as I do something that involves, I guess, what we would label creativity, like write me a limerick about a cat who hates baths. All right, let's start with the one that's probably going to do well. Text DaVinci. A cat named Flo who hated the bath would hiss and spit at the staff no matter how much they tried to give him a good scrub. Fear of water was Flo's biggest gaffe. Okay, now let's switch this over all the way down to Ada. Get rid of the limerick. Try that again. Okay. Chevon Bath. What a beautiful poem. Okay, so I think that illustrates the differences, right? If you can get away with it, use the cheaper models. But generally, the more you pay, the better generated output you'll get. But sometimes it doesn't matter if you're doing simple tasks. But doing things that feel more human-like or creative, generating text, synthesizing things using different voices, I would definitely stick with Text DaVinci. All right, welcome back. Next up, we're going to focus on prompt design or prompt engineering, a really important part of working with any of these APIs, not even just the OpenAI ones, but really any AI tool. Things are so much more open-ended than really any other API that I have ever worked with, where normally things are broken up and structured in a very precise way, right? If you want to get a list of cities from some cities API, you're probably going to request /cities. And then if you want it as JSON, maybe there's some JSON version versus some other version like XML. There's different endpoints that you request, and there's no flexibility whatsoever. But that is not the case here. There's so many possibilities for what we can use these APIs for, but there's also no rules really. There's no structure in place, which means it helps to have some personal guidelines when structuring your own prompts. So some of the key principles here are mostly taken from the OpenAI documentation, some blog posts that they've written. There's also a great GitHub repo that has tons of information about prompt design. I'll include a link to that along with this video. But here are some key points to keep in mind. When you're designing a prompt, you want to include the actual instructions, of course, any data if necessary, so any input data that you're providing, and then also output instructions. What type of output do you want? What format should it be in? Is it a comma-separated list? Is it a JSON output? Is it just a single word that you want? Is it some sort of output that's optimized to work with Python or with JavaScript? Is it a paragraph of text? Is it a table? There's lots of different ways that we can specify what we want OpenAI to give us, or what we want GPT-4, GPT 3.5 to return to us as the output. So I'm going to spend a couple videos showing some examples. And the first part I'll talk about is just the main instructions you provide. When we're writing a prompt, we want to provide clear instructions. So here's a simple example. Complete the sentence. That's our instruction. And then we have our context or our data that we're asking it to work on. Humans are. I'm going to use the playground here just to make our life a bit easier instead of doing this in a notebook and having to send requests, and I might get a rate limit issue. The API has been sort of down and buggy today anyway. So the playground, I've shown it before, but if you're on the OpenAI page or the dashboard when you're signed in, you'll have an option to go to playground. And then here we can select if we want to use chat, or I'm just going to stick with complete, the model, Text DaVinci 03. And I won't touch anything else for now. So if I just ask it, humans are, I'll zoom in a bit, right? I'm not providing instructions. It's still going to try and complete this and give me some output, but I haven't said what I want it to do, right? So it just continues on and on and on. Humans are social creatures who have an innate need to interact with one another. Tell that to my dad. He's the most loner person on earth. They crave companionship and need to establish relationships, blah, 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 right? It just keeps going. So I guess it did complete the sentence, and then it just kept going. So by providing a simple set of instructions up top, or I can do it below and say, complete the above sentence, but I'll say complete the sentence. That's my instructions, and then this is the actual context. There we are. It completed the sentence. Humans are the most intelligent species on Earth. Of course, I could change this in so many ways. One thing to note when you're using the playground, when you have a completion done, that is considered text that's in the file or it's in the editor. So if I click submit now, it's not going to really complete anything because the sentence was already completed. So I need to delete that if I want it to go again. But of course, there's many other things I could do. Instead of complete the sentence, I could say, count the words below. I mean, that's kind of a terrible use for this, but it should work, right? It gives me 2 words. And I guess my point here is these instructions are important. Instead of just asking it to complete something and assuming it will know what you mean when you say humans are and relying on it just continuing on and rambling essentially, we can finely tune exactly what sort of response we get by telling it, count the words below, complete the sentence below, make a poem with the sentence below, analyze the sentiment. There's a million things you can do, but providing some sort of instruction is usually really, really important. Something that I found to be less important, however, the docs do recommend, is using a separator to designate your instructions and then any input or context or data. So they recommend on the OpenAI documentation using 3 pound symbols, octothorpes, whatever you call these, or using triple quotes, something to separate out the instruction versus the rest of the text. Like I said, I haven't found this necessarily to be that important in my experience. I feel like it's way more important to provide good instructions and then to provide this third piece we're going to talk about soon, output instructions. But it's something that I guess you should know about, and it can help clean up your prompts if nothing else, right? So we can try an example here. I don't think we'll see anything different if I just wrote translate the following to, well, I guess we'll just keep going with French. And we don't even have to do this where we write text, but this can be helpful at times when you have more complicated information you want to provide. You could have, tons of instructions, and then finally you can say, here's your data, or here's the text I want you to work on. And then in here we'll say, I really like to eat, what do we like to eat? I really like to eat candy. Okay. So I think this will work just fine without separating this out. In fact, I'm positive it's going to work. There we are. J'aime vraiment manger des bonbons, something like that. But if you were to follow the format specified by the docs, it would look like this. Or we can use the pound symbols. I don't think it will make any impact, and we get the exact same output as you can see there. So just a simple tip, I guess, if you even want to call that a tip. It's more of just passing on some advice from the documentation, although I have found that to be not that critical to actually write out instruction. Another thing that's very important is to reduce any fluffy or imprecise language. Try and be as direct and precise as possible. So this prompt is asking for basically a simple explanation of the role of the Supreme Court in U.S. politics. And one way of doing that would be, write me a simple explanation of the role of the Supreme Court in U.S. politics. But this is pretty fuzzy. What is a simple explanation? Or what if I said something like a short simple explanation? It's going to work. I'll get something. But generally, it's better to be as specific as you can. How many sentences? What makes it simple? Is it simple because it's dumbed down to a lower skill level? Is it simple because it's brief? Does it use, small words and assume no prior knowledge of the Supreme Court or of U.S. politics? It's generally better to do something like, write me a 2 to 3 sentence explanation of the role of the Supreme Court in U.S. politics, geared towards someone with, no prior knowledge of U.S. politics, or something like that. And it should work just fine. Right? It's the highest court in the country, serves the ultimate legal authority. It's responsible for interpreting the laws. This gave me 2 sentences, right? I asked for 2 to 3 and it gave me 2. I'm just being very direct and specific. And it's not like, in our previous example that it wasn't working at all. I can't, let's see if I undo here. Nope, it won't let me undo for some reason. But our previous example, where our prompt was working fine, it just was imprecise. It was fuzzy. It's always better to be very specific and direct. Even if that means some extra tokens in the prompt, it's really not that big of a deal if you're writing an extra sentence or 2 in your explanation. If you have thousands of extra tokens, explaining your prompt, I would definitely make sure that those are important and that they're making a difference, because otherwise it's going to cost, an extra fraction of a cent every time, and you add that up with thousands and thousands of requests, and that could definitely get expensive. So we have a lot more to talk about around output, but for now, I just want to leave those 3 tips there. Be precise and be direct. This one, maybe it works. I haven't noticed it to be that important, but if you're ever getting, a confused response or one that seems like it's mixing up the instructions, you can actually annotate your prompt and say, this is your instruction, using something like 3 pound symbols. And then, of course, most important is actually providing some clear instruction. And we'll see a lot more examples of this. We can do sentiment analysis. We can do summarization. We can ask it to pull out keywords. We can ask it, to do math, although it's not terribly great at that. We can. We have all sorts of things we can provide in the instructions. What's important is to actually provide an instruction instead of just assuming it's going to figure out, what to do. All right. One of the most important pieces of designing a good prompt is specifying output instructions. What type of output do you expect? What format should it be in? How much output should there be? These are all very important questions to ask yourself, and they can make your life a lot easier if you're trying to take the result that we get from, let's say, a GPT completion, and then plug that into a database. You might want to ask for SQL. What if you're trying to plug it into just regular Python code or JavaScript or Ruby or any language? It might be easiest if it's formatted as JSON that you can very easily parse and incorporate. So I'll show some examples. Here we have a prompt that is asking the completion API to extract the place names in the following text. And you can see I've specified the input. Here's the instructions. The input is like the first paragraph of Airbnb's Wikipedia page. And then I specify a desired format. And this desired format says, I want it to look like this. The result you give me should say places, and then have a comma separated list of places. And you don't have to do this using this exact syntax, although this is an easy way to suggest the format that we want. Another option would be to show an example, actually make a comma separated list of places, but let me show you this in action. So I'm just going to grab some text from, this is the Wikipedia article on Alaska. I'm just going to grab something that has some place names and then plug this into the playground. And I'm just using the playground because it's more visual and less buggy right now when the API is down. But this will also work, of course, in the APIs. And then I'm going to ask it to extract a list of place names from the following input text. And if I just run it like this, and I say, here's your input, let's see what it gives us. Okay, so it's a list, right? But it's a bunch of elements separated by new line characters. So if I actually got this response in my as an API call, I would then have a bunch of these new line characters I'd probably need to remove or do something with, not to mention the dashes, dashes, I always mix them up, but you know, those characters there and unnecessary spaces I probably don't want. So visually, if I'm just looking at this, it's easy. This is a great format: Alaska, Texas, California, Montana, Juneau, Sitka, and Anchorage. However, to make it friendlier for plugging into code or into a database or into a CSV file, I can do something like desired format. And we don't have to do it this way. I could just say the format of the output should be X. This is just a nice, simple way of saying it. Desired format. And then I'll say places. If I wanted to give it back to me under the name of places, and then I'll do comma, separated list of names. And let's see how that goes for us. I'm going to delete this. And there we are. We get a comma separated list of names. And if I don't want it to be called places, I just want the list of names. I got to get rid of this. Now it just gives me a comma separated list of names. And I can take this and plug it in easily to a CSV file, for example. And imagine that instead of hard coding this paragraph in, I have like a huge data set, tons of paragraphs of text or tons of comments people have left on, I don't know, my restaurant website or Yelp or Reddit, and I want to extract the place names. And that's just one example. There's a lot you could extract, but let's say I'm doing place names. I would be doing this dynamically in some sort of loop or something where it's repeated on unknown content instead of just hard coding in a paragraph of Alaska, because of course we can just extract those place names ourselves. But I can also say things like, instead of this desired format, maybe I want it to be a JSON array of place names. And let's just see what that does. Okay, so it thinks that I wanted it to give me the name JSON array of place names. So it's not exactly what I want. Let's see if I do it this way. It might think that's part of the desired format. All right. But then it gave me this answer, which I'm not happy about. So I could say down here, answer colon. This is just one approach. And there we are, right? It's no longer saying, here's your answer, and including answer colon. It sees that I've already included that. So then it just fills in the blank. And now I have this perfect JSON array that I'm ready to parse and use immediately in any programming language. Let's try another example. I'll ask it to generate a list of the, let's say, top 5 most populated countries on Earth. And let's just see what it gives me. Okay, so it's a numbered list. And that's what I asked for, just a list of the top 5 most populated countries. But maybe I want to know the populations. So I could also specify with their population. Get rid of, well, it actually just kept going. That's fine. Okay, so it's giving me this result here. Population, colon, and then a numbered list. And that's great to read and look at, but again, working in code, this requires some extra work to actually extract the country name and the population. Not to mention ignoring this, ignoring the numbers, ignoring the dashes, maybe not what we want. So I can do something like this, desired format, and then I'll say maybe we have a lot of choices, but a JSON object with countries, country name as the key, and population as the value. Let's see how that goes. Perfect. So you can see it gave me exactly what I asked for. An object where I have the key, the left side, right, is the name of the country, and then their population on the right. And now I could parse this response if I got it, in Python, parse it with json.loads. I'll show an example of that, and immediately have access to the information that I want, and not have to, use regular expressions or split up a string and loop over it. I don't have to do anything. I have the exact shape that I wanted. So it's really important, especially when you're working with code and you're expecting data back from the API that you want to use in your code. It's really important to ask for the shape of that information, to specify what the data should look like when you get it back. So next up, I'm going to show you some common use cases for the completion model. So things like sentiment analysis, summarization, classification. I'll just show some examples. I'll do one per video, so they'll move along pretty quickly. And the first thing I'll show is summarization. So if I grab something from Wikipedia, it doesn't really matter what, but let's do a more complex article on something I don't know much about. How about the Wikipedia page on archaeology? So I'm going to grab maybe just this whole first couple of paragraphs, and then I'm going to go back to using the playground. So here it is, and I'll just plop this in here, and I'll say, here's your input. And then before this, I'll say, summarize the following text, and then I can specify exactly how I want it to do it, but let's just start by saying summarize the following text. Here's your input. And you can see it gives me a summary. Let's see how long it is. It's not too long. I'm not going to read it out loud, but I'll just quickly, it looks good to me. It's a summary of this first part of the Wikipedia article on archaeology. Now, I could have just asked it to give me a summary of archaeology, but imagine we're doing this dynamically with, reviews on Yelp or posts on Reddit or data that we have from surveys we've done internally at a company or something where we have some data set with thousands of articles or thousands of reviews that we want to summarize. So, of course, I could shrink this down and say I want it to be summarize following text in 2 to 3 sentences. And do something like this. It also is, if you look, it's including the word summary at the beginning. And if I don't want that, I could just start by saying, put your summary here. And that's just an easy way to get only the part that I want. And then I could plug this into a database and not have to worry about it saying summary. I could also do something like desired format. Up top here, desired format, 2 to 3 sentences of text. And let's see if I just get rid of this. And that way it doesn't include the summary at the beginning either, because I gave it a specific format. So that's one option, one way we can use the completion API. And we also will see later on a much more complex example where we'll actually generate a summary of an entire book, a full novel. And that will require managing price, but also managing the context that we're providing each time through, because the model restricts us to how much text we can provide. So we can't give it the full book at once. We're going to have to chunk the book up into a bunch of small pieces and then provide those individually and then get an overall summary. But that's a later project. It's mostly about cost estimating and figuring out how much something will cost ahead of time. When it's complicated, it's not as straightforward as just saying how many tokens is this or how many characters or words is this, but that's coming up soon. Anyway, that's our first use case, summarization. The next use case for the completion API that I'll show is extracting information from text. So let's say that we have a data set of thousands of reviews for different restaurants, and I want to plug them into into the completion API and figure out what items are served at this restaurant and maybe which ones are mentioned the most in different reviews. I want to save them in a database, but all we have are the overall reviews. So this is one of my favorite restaurants. It's no longer with us. Back when I lived in San Francisco, 20th Century Cafe. It closed, unfortunately, during COVID. But let's just grab, I don't know, one of these reviews. Maybe this review to start. And I'll plug it in here. And I'm going to ask it to extract, I don't know, the food names. Extract the food items from the restaurant review below. Or I could just say from the text below. And then I'll tell it, here's your input. And let's see what it gives us. All right, pierogies and honey cake. And as far as I can tell, those are the two names, or the two food items. The honey cake there was very, very, very good. It's a pain to make. I bought the cookbook and tried to make it myself. Anyway, I missed that restaurant. So this is another situation where I could specify, desired format. And I want it to be a JSON list, or let's call it, technically in JSON, it's called an array of food names. And I got to get rid of the output that it already made and try this again. Okay, now it is showing me the text output, which I'm not crazy about. So I'll just trick it. Not really trick it, but I'll say, put your output here. And there we go. We get pierogies and honey cake in an array. And then, of course, I could go and grab another review. And imagine I'm doing this dynamically and have thousands or hundreds of thousands of these reviews in a massive data set. And this one says Russian honey cake, bagels, pastries, coffees, and teas. And then I could build up a list and put them in a database and, keep track of the most mentioned foods or, the most popular items. It's just a very simple use case, but I'm asking it to extract information. So I'm not asking it to summarize. That's what we saw previously. I'm asking it to retrieve specific bits of information. In this case, food items. You could do brand names, names of companies, products, colors. I mean, there's a million things you could ask for where you give it a chunk of text and ask it to get information out. And then I'm telling it, here's the format I want. And this would make it very easy to plug that into Python. The next use case for the completion API we'll cover is sentiment analysis. So sentiment analysis basically involves giving an API or some model a piece of text and asking it to tell us if it's a positive sentiment, neutral, or negative. There's other variations where it's not just those three options, but that's the most common. Is this positive, neutral, or negative? And you could use this to analyze the sentiment around different brands or startups and which stocks to buy based on Reddit comments. Or let's do it just on restaurant reviews. So I have the same Google reviews open for this 20th Century Cafe. And let's find one. Let's start with a negative review. I'm sure there's at least one very negative somewhere, no? Okay, how about this review here? 1 star. And I'll bring this into the playground. I'll paste in the review. I'll say, here's your input. And then I'll ask it to classify the following texts. How about the following text's sentiment as And then I have a choice. Do I just do positive, neutral, or negative? And let's start there. And it says negative. And that makes sense. It's quite a negative review. Let's find a way more positive review. Maybe this one here. Put that in. Of course, you're not going to do this one at a time most of the time. We have a sentiment analysis project later on where we work with Reddit comments. And we're going to, work with hundreds at a time that we're scraping and plugging in. We're not actually manually typing them and copying and pasting. So this one's positive. Let's try one more example. Maybe we'll find a neutral. How about this one here? It's a 3-star review. It says some nice things, some negative things. And yep, it says neutral. All right, so simple example, but that is how we can use the Completion API to perform sentiment analysis. There are separate standalone sentiment analysis APIs out there where you send them text and that's all they do. They'll return to you positive, neutral, or negative. You can set it up to work with numbers, but the point is with OpenAI's tools, with GPT and the Completion API, it's just this Swiss Army knife where we have to tell it exactly what we want it to do. And it will perform the sentiment analysis for us, assuming we ask it to. We could also, if we wanted to work with numbers instead of positive, neutral, or negative, we could do something like desired format, a number, and let's say -1 for negative, 0 for neutral, and 1 for positive. All right, well, it worked, although, I just want the number. I don't want it to also say neutral. We could try finessing the language here, or what I'll do in the next video is show you another option we have at our disposal. But that's a simple example of sentiment analysis. Next up, we're going to talk about the difference between 0-shot prompting and 1-shot or few-shot prompting. So these terms, few-shot prompting, 1-shot, 0-shot, they have to do with basically how many examples are provided in a given prompt. So the term 0-shot prompting or 0-shot means we're not providing any examples. And we're hoping that the model can just figure out what we want it to do based on the prompt without examples. So extract keywords from the below text, and then we'd have some text in here that we wanted to extract from, and we hope that it can just figure out how to extract the keywords. And a lot of the time that works great. I'd say most of the time with the stuff we've done so far, we don't need examples. But there may be times where we want to try a 1-shot or few-shot approach. It basically just means providing examples that hopefully the model can learn from in our prompt. Now, we're not changing the model. We're not training the model overall. We're simply providing a few examples to illustrate what we want. So here's the same prompt in a few-shot approach. Extract keywords from the corresponding text below. We'll put text down here. It's not there right now. And then we give it an example. Here's our first example, and here's the keywords we would expect to get back. Here's our second example. Here are the keywords we expect to get back. Here's our third. Now you show us the keywords that we should get back, or complete those keywords for us. So this can definitely be helpful. I always start with a 0-shot approach. Again, it's just a fancy way of saying no examples. And then if I'm struggling to get the model to do what I want, at that point, I'll incorporate an example or two. So an example of how we could actually use this is from the previous video. We had this classify the following text sentiment as positive, neutral, or negative. Desired format is a number. I want -1 for negative, 0 for neutral, and 1 for positive. Now we could rewrite the prompt. I could probably change this up here, classify the following text sentiment as -1, 0, or 1 based upon the sentiment in the text or something like that. I could rewrite the text, but I want to show you here that I could also just provide an example or two, and it should be able to figure out the format that I want. Because right now what it's giving me is the number 0, but it's also giving me neutral in the parentheses. So what I could do is this, give it an example. Input, and let's just do a very obviously positive input, like I love you so much. And then we could say that the sentiment should be 1, right? If that's supposed to be positive. And that might illustrate that we want only the number back. So this would be a one-shot example, not a few shot, because we only have one example here. And then if I delete this down here, let's see if that's enough. Now it's just giving me a number. Let's try another review here. And by the way, the number it gave me here was 0. This was our neutral review that was a 3 out of 5 star review. So that tracks. Let's try a very negative review. And put that in here. Okay, just get rid of extra space. And let's see what sort of sentiment it gives this super negative one. Is it going? There we go. -1, which is for negative. So I'm not saying that you should do sentiment analysis this way where we're just generating a number. I wanted to show, though, that we can totally change the way that it gives us output, totally change the format. And if it's not picking up on our text instructions very well, which often is a failing on my part or on the prompt writer's part, we can then include an example or two or more, as many as needed. So this would be a one-shot approach. This is a few shot. I mean, technically it's a 2-shot approach. That just means we're providing one or more examples to show the input and then the output that we expect. And it makes a big difference. As you can see in this case, it's now just giving me a number. It's not doing, negative in parentheses, which I didn't want. Okay, so a lot of the time examples can help. Next, I want to show you something that's kind of interesting. I don't know how useful it is day to day, at least for the prompts that I write, but this is something called chain of thought prompting. So here's a word problem, the type that trips many people up, myself included. Alice is 7 years older than Beth, who is 5 years older than Erica. What is the difference between the ages of Alice and Erica if Erica is 30 years old? So if we were going to solve this, I'll start by just seeing what the playground with the completion model comes up with. It says Alice is 37 years old. The difference is 7 years. Okay, now let's see if that's correct. Just as humans here, we know Erica is 30, right? So let's start with that. Erica is 30. And then we know that Alice is 7 years older than Beth, who is 5 years older than Erica, right? So Beth is 5 years older than Erica, meaning she's 35. And Alice is 7 years older than Beth. So Alice should then be 7 years older than 35, right? Which would be 42. So what is the difference between the ages of Alice and Erica? Alice and Erica, that difference is 12. Not the most complicated problem. However, you can see that it got it wrong. It said Alice is 37. That's not correct. Alice is 42. The difference, according to our completion here, is 7 years, but the true difference should be 12 years. So it got it wrong. And there's many, many examples of GPT getting things wrong, of course, especially factual information, which we'll also talk about in a bit. But this is not that complicated, and there's actually a very simple trick that we can use to try and coach it along the right path. And there's a whole paper about this, actually. Large language models are zero-shot reasoners. If we look in the abstract here, there's a piece right here. We show that LLMs, large language models, are decent zero-shot reasoners by simply adding "let's think step by step" before each answer. It's pretty fascinating. If I simply add in "let's think" step by step, and I submit this is what we get. Remember last time it told me the difference was 7 years? Well, now it's telling me the difference between Alice's age and Erica's age is 12 years, right? So it shows me step by step essentially what it's trying to do. Beth is 5 years older than Erica, so Beth is 30 plus 5. It's exactly what I did, right? Alice is 7 years older than Beth, so Alice is 35 plus 7. And the difference is going to be 42 minus 30, which is 12 years. And that's the correct answer. But we weren't getting it until we put in "let's think step by step." Now, like I said, I don't know how useful this is. I'm not writing many prompts that involve, logical reasoning like you see here, but it's pretty nifty that this works. There's a whole data set of word problems you can find online where you could play around and see if it trips up GPT 3.5 or 4, whichever model you're using. And then if you add in, let's think step by step, a lot of the time, it's not a guaranteed fix, but a lot of the time it will get the right answer if it wasn't getting it before. It's pretty fascinating. So we're almost done with this section on prompt design or prompt engineering. I just want to show one more example or a use case for the text completion API. So we've already seen summarization. What else have we seen? Sentiment analysis, keyword extraction. Next, we're going to talk about transformation. So transformation just means taking input text and transforming it to some sort of output. Often, by far the most common example would be translating from one language to the next. So we can do that. And I've already shown some of this, but why don't we do a more complex translation? Translate the following text to Spanish, French, and how about, why don't we do Japanese? Okay. And then I'll give it some text and we'll do something very simple like, my favorite color is purple, just to keep it simple. Okay, so when I submit this, it's going to transform each one of those, hopefully. Mi color favorite, I don't really speak Spanish, es morado, ma couleur préférée. Is that how you say purple in French? Apparently it is. And let's try the Japanese. And according to Google Translate, that's correct in Japanese. Although, of course, I could have just plugged that back into the model and asked it to translate Japanese to English, and we could test it that way. And just to circle back to something we've already seen, I could specify I wanted to give it these 3 pairs back to me, not just as text, but maybe in JSON format. Translate, how about the output should be a JSON object. Maybe I want to plug this in to a database somewhere. Let's get rid of that. And there we go. It gives me an object where Spanish is set to the correct translation, French is set to the French translation, Japanese is set to the Japanese translation. And of course, you could pass more text in there, but I'll show another example. We can transform text in many other ways. So one of the examples on the OpenAI documentation is to take first-person text, like, I love to ski so much, and today I went skiing with my best friends, and I fell really hard and broke 34 bones. I cried for hours. Now I am almost dead. All right, so we've got some first-person speech or text. And we'll say, transform the following text from first person. We might not even need to say from first person. We'll just say to third person. Like that. Let's see what it does. He loves to ski so much. Today he went skiing with his best friends and he fell really hard and broke 34 bones. He cried for hours. Now he is almost dead. And I could rewrite it to say, third person female, for example. She loves to ski so much. What about if I try and change the tense? Transform the following text to third person female in the future tense. She will love skiing so much in the future. Today she went skiing with her best friends and she fell really hard and broke 34 bones. She will cry for hours. Now she will be almost dead. So, it tried. I've never done that with the tense, and I made it hard because it says today, right? And now. So it's kind of hard to turn those words into future tense without completely removing those words, right? Anyway, just a silly example, but that's another way we can transform text from one format to another. So we can translate languages, we can change, perspectives. What do you call it? First person, second person, third person. I don't know what you call that. But we can also do things like kind of fun examples, transform each Let's do movie title to emojis. Let's see if we can do the movie Cocaine Bear. Let's see. Yeah, that's pretty good for Cocaine Bear, right? So it's transforming text in another way. Let's try one more. How about the Lion King? Should be an easy one. Yeah, pretty good. All right, so another way of transforming text. There's a lot of things you can do, and that's pretty much it.